Hello, I'm Peter Sefton. Mike Lynch is at home in Sydney. Right, so I couldn't resist this. The theme of this session is something about holding hands, and I just happen to have been in a band called Living Holding Hands that won the Sydney University Band Competition in 1987. Not very good metadata on this. I know it was 1987. I don't know what month it was. Tuesday the 14th. We played one of the gigs. And we're now at a university. I'm now at a university about 500 metres down the road from there. So I think for once, actually, well, the papers we're hearing really, really tightly aligned. So a lot of the things I'm going to say are very similar to what you've heard. I think we come from a slightly different kind of institution, though. You'll see. You'll be able to tell from the pictures. But one of the things I wanted to kind of put up front is that we're working in an environment where we're trying to do services for researchers. So we work in the e-research group at UTS. And we're part of the IT department, but really, I think that we really report through to the research side of the university as much as possible. And that's sort of run by the Deputy Vice Chancellor of Research, big, I guess, in some other places. But the kinds of, this is not actually a complete list of services, but the kinds of services that we have are, there's staff profiles, there are research information systems, called CRIS in some parts of the world, grant management, and if you're a researcher, you have to deal with all of these different systems, right? And as a researcher, you come and you get, corporate email, you get Microsoft Word and those sorts of things from IT, and you get the finance system, and you get all this other stuff, right? And it can be very frustrating. And one of the things that I think has come through in some of the other presentations, but I wanted to emphasise is we are not the centre of the universe. There are thousands of things that people have to deal with, and we're trying to bear this in mind when we're designing things. Okay, so what I'm going to go through here are give you sort of a contextualised view of how we're looking at research data management at a university, and that context includes all of those different systems, and trying to take a researcher-centric view of how we do design. There's a couple of specific use cases that we're working on right now. As usual, when you put in a paper for something like this, you project just a little bit into the future about where you think you might be, and we might not be as far as the abstract implied we were. But I think there's some insight in where we're at, and like talking about the kinds of decisions about what, how you think build systems and so on. Very, very similar things to the last presentation. But I know I'll actually talk about two very concrete things that we're dealing with that are part of this broader thing. And then we're also going to discuss, one of the reviewers really asked to emphasise access control, so that's one of the things we're going to talk about. Okay, so the first bit of context is we have a facility at the university which is called the Data Arena. So this is a round room with 6 projectors driven by 6 computers projecting a 3D immersive image. And my colleague Ben up the front here is the technical director of that. He's got a background, he had a background in high performance computing. So he would have been in the bar when my band was playing. And the gentleman behind us is the Deputy Vice Chancellor for Research. They're standing in this facility. This thing is an expensive sort of showcase facility, and we've got some funding, sort of government funding from the Australian National Data Service, and we decided to focus on making sure that the data that goes into this facility is actually well looked after. So we had a project with it. The brief was basically, we want to put a research data repository in front of this facility so that anybody showing up to do a process project at the facility has to deposit their data before they're allowed to play. By default, we'll make things open, and then we'll try and sort of use this as a microcosm for the broader changes that are happening in research. People have to go through research data management planning, describe their data and deposit it somewhere. So I've been thinking for a long time, for several months, about what, do we put in a hydro thing? Do we put in what would actually suit? So I won't give this away, but we actually picked a particular application to do this. But the context made it quite tricky. Okay, so this is my team talking to the data arena technical director. So we went and asked Ben, what are your requirements for a data repository to help manage this? So he got that this is a good idea, but they've done 20 projects or so now, and that's growing. And in a few years there'll be hundreds of things, and having them just arranged on folders on the disk is actually not going to work anymore. So we asked him, what do you want? He said, I want an NFS mount. I want high-speed access, 2x6 compute nodes, and that was the requirement. This is the sort of the director of the facility. And what about metadata? I asked about metadata, and the answer was, well, yeah, okay, I like metadata, but I want it embedded in the files. Okay, so this is someone who's worked in visualization, he's worked in the movie industry, and understands about technical metadata embedded in files, but the sort of metadata we're interested in, things like grant funding and so on, probably don't belong in the files. But this is what the actual research person who runs this facility actually thinks, right? So we've got a fair bit of work to try and come up with something that meets these requirements. We definitely have to meet these requirements in this conversation, but yeah, that's a tricky thing. And the other part of this, so the other facility we're dealing with is the microbial imaging facility. And this is another part of the university, so there's a bunch of facilities. I've just highlighted this on the facilities page. And the microbial imaging facility has, unsurprisingly, a lot of microscopes, and they generate data from the microscopes. And that needs to be looked after. And we have a very intimate relationship with this data. In my team, eResearch, we've been providing storage for the data for several years, and it's sitting in a bunch of folders. And we have to look at permissions on the folders. And we really wanted to give them a repository as well, with some metadata and some management. They want to be able to share things. And there are a couple of applications in this space that we've been looking at. This one called Amero, which is an open microscopy thing, which has a lot of services. Not so much a repository, but it has a lot of, you can do a lot of transformations and so on. It transforms proprietary microscope data formats into open formats, variations of TIFF, it extracts metadata, those kinds of things. And there's another one called MyTardis, which I'll show you in a minute, which is a piece of open source software that's sort of evolved into this data capture arena. So I didn't test this. I wanted to see if this video works, so you can just get it. Is it working? Yeah. 20. It's really great planning.
It's making me thirsty.
Well, there's no sound, so I don't think this is going to. Don't think this is going to.
Yeah, I'm sorry, what's your presentation about?
Okay, sorry about that. So, I was just trying to give you a look at that. So Cynthia, who's in that, leave my presentation here. So the video was Cynthia Whitchurch, who runs the facility, talking about how they use the data arena to take data that's come from their microscopes, been processed through an image pipeline to produce visualizations that they can show in this kind of immersive space, and how important that is for sort of gaining insight. So you can stand in the middle of a cell and do things. One of the other things that they do is you take images that have been generated from a microscope, which is kind of a movie, so a series of time slices of bacteria moving around on the surface. And this is important for infection control. So you want to make sure that you can keep bacteria out of places that you don't want them, like people. And you might be wanting to treat things like syringes and so on, catheters. So they've got these images of the little things moving. You run that through some image processing software which actually recognises the individual things, labels them, and produces a data file which is effectively a spreadsheet that has the coordinates of each of these little things. Then that gets fed into some software called Houdini, which actually comes from the movie industry, which is used for kind of doing animations. Ben, who runs the facility, worked on Happy Feet 2, the senior technical people. They used Houdini to make that movie, but now they're doing the same thing with the microbes. Right? So the result of that is we get a visualization which actually tracks what's happening, and you can show things like orientation and see what's happening. You're trying when the researchers are doing this research into things like infection control. That's what Cynthia was going to talk about, much better. Okay, so I'll just go through some of the sort of principles and approaches that we take into this work. So some good things. We've actually got a fair bit of time, so if you want to argue with me, I'll entertain arguments up to a point in the presentation. So we want to use linked data principles. We want to have high quality metadata, use URIs as names for things, and as far as possible ban strings. So string is okay for a title or a description for a data set, but a string is not okay for identifying a person. We've got ORCIDs now, and there's a push from the university to get the researchers to identify themselves using ORCID. So we're going to be doing lookups for that. You can't type in a string for a grant ID because all the major Australian grants have URIs thanks to sort of community effort and the government. So like in other places in the world, we don't have to collect bad string-based metadata for this stuff. So, well, I just like to go through this on every project, make sure everybody understands. Fedora seems good, right? It seems like a good thing. I'm not sure if it's quite extensive that nobody ever got fired for applying IBM thing yet, but we already had Fedora. We had a Fedora free repository, which I won't talk a lot about. But we had already had a Fedora free as a back-end for storing things, so it makes sense to stick with that. So PCDM, the Portland Common Data Model, seems very like a very important step. That it means that we can start to model data collections that might be living in more ephemeral services, something like a Mecca, which I think is a really great tool for getting work done. But I probably wouldn't expect to last, like the Mecca instance, to last more than maybe 5 years at the maximum. So the PHP code is going to get very dangerous and hard to maintain over that time. But PCDM means we can map, like a Mecca is actually collection-based, we can map that into a well-described collection and deposit that somewhere else. And it might be reconstituted into a new service later on, or it might just be kept in an archive. So we think PCDM is important. Mike added that PCDM actually might help set some implementation arguments. I'd like to be able to talk to software developers we're hiring in to do data capture work and say something, okay, you organise it however you want, but it has to have a PCDM compliant interface on it, so we can pull things out as collections. No, you don't get to override, decades of repository, a decade at least of repository experience, and with your own architecture, you will do it this way. So we think that's good. We're really operating in a kind of small pieces, loosely joined Unix type environment. We've got a very small team, and we want to be able to use lightweight, simple services that we can hook up with scripts rather than big projects. We probably can't take on building a Hydra head, but we can take components that might be complete and join them up. And composability. Mike reads mathematics theory for fun and likes the idea of composable functions. Okay, so there are some scary things though. I love PCDM, but I'm a bit worried about some of the discussions going off into realms. So, it's good, and we had some very stimulating discussions. There was a PCDM catch up earlier in the week, and it's very nice to to deal in those very abstract terms, but they are completely irrelevant to the kinds of research, questions that people are asking with the microbes, right? And I'm a bit worried that we think these things can get too complicated. And OIRE, I got excited about that too, and it doesn't seem to be really a thing now. Another thing that I think is worth thinking about, and I'd appreciate some dialogue about this maybe over a drink sometime, is if you're building a repository and you're trying to do the kind of archival preservation-y kind of stable end of things, so you have states of objects which probably are either it's there or for some reason we've had to retire it. Right? Those are the two states in that kind of repository versus all the workflow stuff that you put in the front end, right? So when you're putting things into the repository, things are going through review states and so on. I'm a bit concerned about some of the risks of and the maintenance load of putting those two things into one thing, which is kind of how most of our repositories are. You have a key prints and DSpace, they're definitely like that, and some of the Hydra implementations are a bit like that. And I know, like in the last couple of weeks, there have been discussions on, I think the Hydra list, the Fedora list about, state in, and I think my impulse would be to just have two separate things, right? So move the workflow over into a workflow tool, and then have our approach and our architecture at the moment is just have a Fedora backend where you put things in there and that's what they stay there, right? It doesn't do anything. It doesn't actually have an interface on it apart from the APIs, probably. But persuade me otherwise, right? This is up for debate. And the other thing is just going back to what Ben said, right? The data arena director wanting to be able to mount the files. I went through a big, well-funded project in Australia working on an application for research data. It was human communication science data, so that started with linguistics, but it was going to include musicology and psychology and a whole lot of stuff. I presented this 2 years ago. Tom was chairing the session. It worked really well, but when we got to dealing with hard lists of items that were like 1,000 items coming out of a repository with several thousand items in it, performance was really, really bad on the Hydra thing that we were working with because of the overhead of having a Fedora 3 behind. And actually, the researchers wanted and would have been better served with their files on a file system and some RDF, and maybe the item lists are working with could have been just a list of URIs. It could have been a really lightweight text file. The thing we did for them was really over-engineered, and it was because to us everything with the, let's say I've got mixed up here, but it looks like a repository problem, right? Because we're the repository people, we think we have to put in a repository for everything. Okay, so sort of related to this, all that comes down to we're scared of the idea of monoliths, right? So Mike and I were sitting around thinking, what can we use as a metaphor for monoliths that we put into the presentation, talking about 2001 or whatever, and so on. And we realised we were sitting in one. So this is the ugliest building in Sydney, technology, and we sit in there. This is just here as a metaphor that we actually. All those things I said before, about things we think are good, and the things we think are scary, actually pushing us towards a distributed architecture, which we've heard, like the other two presentations have talked about, really distributed architectures with lots of services rather than one thing where you're just going to come and do everything in one place. I also couldn't resist this one. So this is Heracles or Hercules slaying a Hydra.
Nick's getting excited.
So the working title for our little tiny repository code, which is really not much and not built, would be Heracles. What the thing that we're talking about is actually starting to build a data research research data management architecture at the university which ties together lots of different research groups, but the two we're starting with, which need to join up, are the microbial imaging people and the data arena people. They're already working together, so we know we need those two bits. And we also know that at the data arena, people are going to show up with random data sets. Spreadsheets, I've had point cloud data, which has come from people putting LiDAR scanners on drones and flying them through limestone caves, so probably similar to the Rotunda stuff. And that gets visualised in the data arena. People will show up with all sorts of different things. So we need to have a kind of front door where they can deposit stuff. But to do this, we actually also have to worry about access control. So we actually have to take quite seriously in the imaging stuff. People need to be able to establish IP ownership. If we're talking about microbial, like we're talking about infection control, there are potentially patents in that area. So we can't just have everything open, and we need to have end-to-end access control, which is not something that you sort of get out of the box with a typical repository. We have to think this through and engineer it. Fedora 4 looks like it's really well engineered for that. So we're going to use this web ACL stuff. Okay. So this, getting to the kind of actual, the inside and the design about what we're going to do here, that joins these up. So here's an interaction diagram where a researcher is sort of talking to an imaginary application called data splaying. It's like mansplaining, but it's kind of better. So the researcher says, I'm doing a project. What kind of project are you doing? I'm visualising bacteria on catheters. Okay, so is it funded and can you release the data? So we answer those questions. Yeah. Okay, so I'm going to give you a project space. So the system has actually gone from being a repository with a deposit to a provisioning system. This is quite a common pattern. People are putting data management planning tools as the first thing you interact with, and that gives you space typically on a storage device. But what we've decided to do with the data arena people is we're actually going to give people a project, and we're going to give them a project in. It's a repository, but it's not a repository like we talked about. We're actually going to give them a project in GitLab, which is like GitHub. It's an open source version of that. So it's an appropriate thing for people developing code to do visualization, because the stuff that happens in those viz facilities is actually project-based. It's like iterative code development. People need access to the files. So we have to do a few tricks. But we can actually say, all right, so we've got a bunch of images here. We're going to put them into a GitLab all ready to go. Because the images are big, we don't actually give you a copy of the image. We might give you a bag in a baguette format with links back to the images in the other repository. So we have, like one of these distributed architectures, or we might use the Git large file support. That's a kind of implementation detail, but we're going to give you a space to work on this stuff. Okay, so now the actual systems we're putting in. So the one we're going to put in at the microbial imaging facility end is this. This is a screenshot from MyTARDIS, Australian government funded thing. This is at synchrotron at Monash, big particle accelerator thing. You fire particles at things so that you can visualise them. And this is well established, not very pretty, but functional thing which understands lots of different kinds of scientific images. If we use it, it works. So we're going to put that in, almost certainly. We're working right now, trialling this with the researchers. And the thing we're going to put in the data arena is this, also not very pretty. It's not as usable as GitHub, but it is open source and we can host it ourselves. So this is GitLab, and it actually is what we think is the appropriate repository for the working stuff that's going on at the imaging facility, at the visualization facility, at the data arena. So you can have your code. The data is probably imported by reference, as I said before, but you can develop all the code to do the project. And what we want to do is actually inject some good README files into this at the beginning, so we actually know what's the grant funding, what license can this be released under. So the same as you do with an open source project, at least get the license in there. So we have an application which kind of pushes metadata into this system. Then at the end of the project, the rest of it should be self-documented. If the programmers have been doing a good job, and they do, then the code will all be documented, all the visualization pipelines will be documented, And we can reuse these, right? This is what Git is really, really good for. We can take a visualization pipeline developed for somebody, you can clone your own version of it, fork it, do something on a new set of data. Okay, so getting stuff in, we're going to be pulling things in from the microscopes. We're going to be pulling things in from share-sync services like, not Dropbox, but OwnCloud, where people are keeping the data. And that goes into this kind of thing where we've got the data, we've got descriptive metadata and RDF, and the access control is always traveling with it. Getting stuff out, a similar kind of story. And the overall architecture looks like this, so it's not kind of just, a big repository. I've left a lot off this, but so this is the Vitalist bit here. The data spline application that I was talking about before will kind of be provisioning things. So it will provision stuff right down in the storage layer here. You say you're starting a new project, it could give you some storage. It could give you a new project in the, where is it? The data arena repository, sort of right in the center, which is running GitLab. And all these things are hooked up to each other in kind of a grid arrangement. So the kind of metaphor for this is like, this is like very like a 2-second Google search to find the European electricity grid, but this is like showing just interconnect, right? There's no center to this. The way these electricity distribution networks work, it's people sharing electricity, sharing, charge each other money for it, but you send it around the grid, right? So there is kind of no center to this architecture. So we do have a repository, and it might have accidentally been in the center of the diagram, but that diagram was laid out by a machine, not by me. And it's performing one function, it's doing the archival preservation thing, but the researchers, that's not their primary concern. Their primary concern is their project work. So this is kind of the way we're thinking about this. And maybe when I said microservices in the abstract, we really meant something like maybe a bit more macro than that, but they're kind of mini services. It's not a monolithic single repository. Okay, so that's it.